Okay, in this problem we've got two binomials to square. Each of them is a difference of two terms. And we have to do the squaring of the stuff in the, here until we have to do the squaring first before we multiply times the numbers on the outside. Here's the formula we've been using to square a binomial of this form. We square the first term, then we multiply a times b, the two terms in the binomial, and double that to get two ab's, with a negative in the middle if there was a negative in the middle here. Finally, we add the square of the final term, the b, so we add b squared on the end. We're going to follow this pattern for each of these binomials in the problem as we square them. So to begin with, we have 2 times 2r times 2r is 4r squared, and there's a negative in the middle. 2r times 3s is 6rs, and if we double 6rs, we have 12rs. Finally, we add the square of 3s. 3s times 3s is 9s squared. And now we add 3 times squaring this binomial, r squared, the first term squared. If we multiply r times 2s, we have 2rs. And if we double 2rs, we have 4rs. And that's a negative in the middle. It's negative 4rs. Finally, 2s times 2s is 4s squared. So there we have to add that on the end. Now we've squared both of those binomials. Now we can multiply times the coefficients that were in front. Distributing the 2 here and distributing the 3 to the second set of parentheses, we end up with 2 times 4r squared is 8r squared. 2 times negative 12rs is negative 24rs. 2 times 9 is 18, so 18s squared. Distributing the 3 here, we end up with 3r squared. And 3 times negative 4rs is negative 12rs. And finally, 3 times 4s squared is 12s squared. Now we can combine all the like terms. And we have here 8r squareds plus 3r squareds. So that adds up to 11r squareds. Then we have negative 24rs and negative 12rs. Those add up then to negative 36rs. And finally we have 18s squared plus 12s squared. And that adds up to 30s squared. So 30s squared. And so our expression simplifies to this trinomial.